Tell me when. Okay. So the question I just asked is, we now know that we have this site that slopes up. We know that there's a parking visitor center way down the hill. We know that we have 3 access points, one here, and one here. Okay. We know that the client is asking us to either hide the building or completely show it, do not put it halfway in between. All right? How does that information influence the design of the building? Absolutely. It influences where the entrance is, right? So for the entrance, you are required to have what is called an axial approach. That is a frontal approach, okay? And you're going to put your building and design the access point, the entry porch, so that it is directly in front of you as you walk up to the building, okay? The exception to that is going to be this one here, right? Approach number 1, because for approach number 1, right, you're going to have to create a secondary porch that brings you around the corner to the primary porch. Okay? All right. So those are the factors that you guys need to take into consideration as you start to approach this initial project. Now, how many minutes are we at?
1.
1?
15, sorry.
Okay. Remember that this thing is going to require you that you keep your orientation of the building so that it is directed to the cardinal axes of the compass. So how many of you in your 121 class have already covered sun, earth tools? So some of you have, some of you haven't? No? Which class are you in? Marisol? Okay, so Mari should be covering that this week. Okay? So one of the things that's going to be covered in the other class is this idea of how the sun moves in relation to the earth. Which direction does the sun set? It sets exactly west, right? Is that true for the whole year? How many of you say yes? Raise your hand. Straight up. No, none of this. Straight up. How many of you say no? Raise your hands. You didn't vote. You're not allowed to not vote. You have to vote. Don't do it because of you. We got to do it over. How many of you think that the sun sets exactly west every day of the year? Raise your hands. Straight up. Come on, man. Straight up. And how many of you do not think it does? Okay, those of you that say it does not are correct. The sun sets true exact west only 2 days out of the year. And those are the 2 days of the solstices, or no, the equinoxes. Okay, the equinox is coming up, incidentally. The equinox for this year will be, I believe, on September 22nd, 3 days before my birthday. Okay? Now, one of the things to understand is that the equinox means equal parts of day and night. So on the equinox, you'll be able to set your timer, and when the sun clears the horizon, the first instant it clears the horizon, 12 hours later, it will be sinking below the horizon on the opposite side. Okay? So on that day of the year, the sun rises exactly east, goes through the sky, and sets exactly west. That's 2 times a year, in March and in September. All right? And those are called the equinoxes. All right? What are the other time periods of the year called? Anybody know? Solstices. So there's the summer solstice, and there's the summer solstice and the winter solstice. What are the two equinoxes called? You guys know? Vernal and autumnal. Very good. Vernal is spring. Autumnal is the fall equinox. Okay? And those are the dates, right, in the calendar where the sun reaches some sort of a turning point. Okay? Or it's a halfway point between the two turning points. All right, so what day of the year do you have to design for? Huh? No, your document's requesting some specific stuff. So what are you looking for? What are you trying to do? What are the requirements? What was the requirement? Can somebody read it to me? I'll give you a hint. There's a piece of artwork. Something has to happen to it. What is it?
The sun has to shine on an artwork and a glass poster.
Okay, and you have to know where the sun is in order to design a window that will illuminate those pieces at a certain time of the year. Anybody ever watch the old Indiana Jones series? No? Nobody's ever seen them? No, it's the one where I don't know, he's like, there's always Nazis involved. And he's inside of one of the pyramids or something, and he has this thing and he sticks it in, and it's got this, like, the sun comes through and it shines through that and it illuminates something. Ever saw that? No? Wow, these old, nobody likes these old movies. Huh?
Yeah, I've seen it.
You've seen it. All right, one guy's seen it. At any rate, so this little building that you guys are working on, right, is going to require that you understand how the sun moves through the sky, because you've got to cut windows and decide where you're putting the object. Okay? Just so that you guys understand, at the equinoxes, the sun is going to rise exactly east. It's going to track through the southern hemisphere to where and this is important, you guys need to write this one down. At solar noon. Now anybody know what solar noon is? Huh? It's not 12 o'clock.
When the sun is exactly halfway.
When the sun is exactly halfway from sunrise to sunset. Now why is it not the time? It changes throughout the year, but there's something else going on. Let me ask you guys a question. You guys know where San Francisco is, right? Do you guys know where Blythe is? Blythe, California? Yeah, Blythe is at the other end of the state, right? It's where Highway 1 enters into Arizona. Or not Highway 1, Highway 10 enters into Arizona. Okay? So I got a question. So if one of you guys is in San Francisco and one of you guys is in Blythe, and you guys are going to watch the sunrise, and the person in Blythe is on the phone and they're talking with the person in San Francisco, and they go, "Oh, there it is, it just cracked the horizon, sunrise." Is the person in San Francisco see it? No, because they're further around the globe, right? They're not going to see it for probably another 20, 30 minutes or maybe longer. And that's why the times are based on what's called the time zone, right? And the time zone encompasses a wide swath, right, of latitude, okay? Or along the line of latitude. It's actually encompassing a wide swath of longitude. So it doesn't work as far as 12 o'clock noon. It probably does at some point in the middle, right? Between where the time zone starts and where it ends. Somewhere in the middle, 12 o'clock noon is the same as solar noon. But for the rest of the time zone, it's not. So it's important to note that you guys are going to be working with the idea of solar noon. And what I want you guys to understand is that in the summertime, the sun actually rises, right? It actually rises north of east, back here. So if that's east, the sun rises back here. And then it tracks through the sky, and this is at our latitude, to a point that's about 78 degrees up from the horizon. And then it sets north of west, clear back here. Okay? And we're going to be going through this more carefully in the other classes. At the equinoxes, right? So that was summer. In the equinoxes, the sun rises exactly east. It travels through a point at solar noon that I think is somewhere about 50 degrees up from the horizon. When I say the elevation or the altitude, that is the distance from the horizon up to where the sun is. So remember, the first one was way up here, right? Really steep. The next one is down here. So the sun rises in the east, goes to solar noon, somewhere around 50 degrees or so. You guys will be able to tell by looking at sun earth tools, right? And then it sets exactly west. Okay, now we'll take a look at winter. In wintertime, the sun actually rises south of east. So it's rising over here, and it only comes up to about that angle, which is about 32 degrees up from the horizon, right? And it sets south of west, okay? So that's one of the things that you guys kind of got to wrap your head around, is that the sun, right, is in a different place throughout the year at solar noon from summer to winter, and then it reverses and comes back the other direction. All right, go ahead and stop it.